Hey everyone, welcome back to my channel. In this tutorial, I'm going to demonstrate how to produce results from a one sample proportion test, especially for binary variable here in this example, female and black. So the purpose of this test is to understand, for example, let's say you have conducted a survey on 1,000 people in your city, and this 1,000 population actually it would be your sample. And what we expect in a probability sampling is that your sample would represent your population characteristics, right? So then if you know already from your census data that female is 50% of the population, then in your sample, you want to see the exact representation of the female in your sample, right? So therefore, we already know for our case that female constitutes 50% of the population in the sampling area that we have conducted our study. So therefore, we want to see 0.5 proportion or 50% for the female people, right? So and let's first see by tabulating female. Execute the selection and see the results for here. This is the tab command and or tabulate command. So for female, you can see the female is 52.52%, right? So we wanted to see it 50%. So now we see this is different from 50%, but we do not yet know whether this increase or this difference is statistically significant or not. So one sample proportion test exactly produces the results for confirming that it is significantly different or not, right? So the command is peer test, which is proportion test, and then the name of the variable, which is female, and then we specify the value for the female, right? So the value is 0.5. This is the proportion. So we want to see we are specifying that female equals 50%. So then I'm selecting this command and execute a selection, and now I see the results. So from all of them, I just see it here. This is the null hypothesis that says that proportion is 50%. So female proportion, P equals proportion of female, right? So P equals 50%. So this is the null hypothesis, and null hypothesis says that female equals 50%. So the alternative hypothesis that no, female is not 50%, but significantly different from 50%. So what we look at is, as I previously mentioned, that this middle one, because we see this absolute symbols in Z. So this is the G test of significance. So therefore, the value, this is two-tail test, and these are one-tail test, two left and right tail, right? So now we can see this value is less than 0.05, which means that we reject the null hypothesis that the female is 50%, and accept the alternative hypothesis that female's representation in the sample is significantly different from 50%. Okay, so now I can talk about the solutions to this problem. Like if you conduct a similar study, you may want to stratify your sample by these categories, right? If you know that female is 50%, so then you stratify them and collect data from 50% of the female. So you will probably know what stratified sampling is. So this is not the same as simple random sampling, but it's stratified sampling. If you know that you need the exact representation for certain categories, then you really need, especially when certain categories have really low number of population. So then you have the risk of conducting the study that produces, conducting the survey that produces really different representation for that category of population. Okay. So I'm gonna do the exact same thing for, and also one more thing. You can if your particular category is not representative of your population, then what you can do is to do the weighting in Stata. There's a specific way of weighting it in Stata for analysis. So that's a discussion for another day. So now I'm going to do the same thing for the black variable. And tabulate black, and now you see the difference, and black is 10.49%. But from the population census data, we know that black is 13%. Therefore, we want it to be 13%, right, in the sample. So now here again, that 10.49%, and we wanted it to be 13%. So that is significantly different from 13%. So this is the null hypothesis, that's black is 13%, but actually black is significantly different than 13%. And that's confirmed by this two-tailed significance z-test of significance, right? So that's how you conduct your one sample proportion test for binary variable. Thanks for watching. If you really find my tutorial helpful, please subscribe my channel, and also like, comment, and share. I'll share this data file and also the do file that I have used for this demonstration. Thanks for watching again.